Hello everyone. Today we are going to solve one of the interesting problem around the linked list. So basically we have the linked list and we have to figure out if there is any cycle into the linked list. So that's all we have to do. So we are getting provided with the head of the linked list and we are just need to determine if there is a cycle. So by looking at this example 3204, you can see there is a cycle. In example 2, there is a cycle and all this. In example 3, there is only one node. So there is no cycle into it. So that's all. Let's get back to the pen and paper. We will try to solve this. So first thing we have to understand like if you are not aware about the solution, there can be multiple solutions for this, and I will be discussing a couple of solutions for this. First is using a hash set. So basically, you can think of a hash set is as a data structure which stores all the unique elements. So what we can do, we can just visit each node, and at each step, we can just store a node into the hash set. And when we are storing, this is stored, this is stored, this is stored, this is stored, and after that we are coming back to the same node again. So we can say this is a already visited node into the hash, and we can say there is a cycle. So if there is cycle, we can revisit the visited node. So that's all regarding the hash set. Let me write down the algorithm. Iterate over the list, store each element, each node in hash set, check if it is already present. Already present. If yes, then return true, else at last return false. Regarding solution 2, I am going to tell you one story. So this is regarding a racetrack. Suppose I am just drawing one of the racetrack. Can you see there is a racetrack and there is a one loop into the racetrack. And there are two cars. First is a slow car and the second is a fast car. So slow car and there is a fast car. Slow car runs at a speed of 10 km per hour and fast car runs at a 20 km per hour. So there are a couple of observations. First is fast car will enter the loop first because speed is highest. So observations is fast car will enter loop first and eventually slow car will also enter the loop and they will start revolving into the loop both the cars. Eventually slow car will be in the loop in the now by using a speed of a relativity slow car is here, fast car is here. Can we say that because fast car has a twice of a speed as a slow car, so if they are moving into the cycle, moving into the circle, they will meet at some point. So suppose this is a point where slow and fast car meet into the cycle. So can we say that definitely they will meet into the circle. So if that is the case, can we say that there is a cycle? Yes, there is a. Now we have to check how can this imply to our example. Let me copy this diagram. Suppose this is a diagram. So again, this is a slow car. This is a fast car. Slow car runs at a one step, and a fast car runs at a two step. at each iteration. So after first iteration, the slow car will be on the second node and fast car will be on the third node. Can we say that? Let me strike through this. So slow car will be here and fast car will be here. After second iteration, slow car will be on the third node and fast car will come here and again here because of the cycle. Let me strike through this. So slow car will be here and fast car will be here. After third iteration, slow car will be on the fourth node and fast car will be also on the slow and fast. Can we say that they have made each other into the cycle? Definitely yes. So this identifies cycle. Now the question is, if there is a no cycle, how can we figure out that? If there is a no cycle, let me rub this. Suppose the same things like slow and fast. Again, we will just try through after first iteration, slow will be here, fast will be here. After second iteration, slow will be on the next node and fast will be on the null, which is the end of the list. Can we say that we have to iterate until the point fast is not null? Until fast is not null. Can we say that? Yes. Again, let me copy this example for odd numbers. Let me take a slow and fast pointer. So slow will be here. Let me strike through this after first iteration and fast will be here. As there is a no next of next node, we don't want to iterate further. So we will just stop here. So whenever fast dot next is not null, then only we will just iterate into the linked list. Otherwise, we will just stop. So these are the two conditions. So first is we will have a loop like a while. Let me copy this condition. So this is a first condition and this is a second condition. Until these two are true, we can just move slow by one step, fast by two step, and if they are equal, if they are equal, just return true. That's all. Just return true. So that is all regarding the algorithm. And time and space complexity will be, as we have seen, time complexity will be O of n because we are visiting each element only once, and space complexity will be O of n. So that's all regarding this algorithm. We have seen solution one like using hash set. So the time complexity and space complexity for a hash set will be O of n will be same because we are visiting each element. And in worst case, we are storing all the nodes if there is a no cycle. So that's all regarding the time and space complexity of solution one. Then we have seen the example of a racetrack and some observations. And we have seen example we derived to the algorithm complexity analysis. So that's all regarding this. Let's try to code this. First thing is if root is none. If head is a none, then return head. Else take a slow, fast, and while fast is not none and fast dot next is not none. Move the slow by one step. Move the fast by one step. Fast by two steps. And if slow is equal to fast, then return true, else return false. So that's all regarding the solution. Let's try to submit this. Yeah, it is working fine. If you have any further doubts, any questions, please feel free to drop a comment on the video. ठीक है चलो बाय एवरीवन